In this video, I will tell you about mirror and scale command of AutoCAD. So here in this case, we have the simple geometry and a text here, and you can create the mirror image of both of these geometries in AutoCAD. So I'll start with this simple geometry here. So in order to create a mirror image of this geometry, select the mirror tool from the modify panel, and now look at the command line, which prompts you to select the objects. So select the object and press enter. Now the command line prompts you to specify the first point of mirror line. So click anywhere in the drawing area, that will be the first point, and now click at the second point of mirror line. And now you can see that a mirrored copy of original object will be made. And now click here and now look at the command line. So now it prompts you to specify whether you want to erase the source object or not. So we don't want to erase this source object. So I'll select no, the default value, and simply press enter. So here we have the mirrored image. Now let's say that we want to make a mirror image of both of these objects on the upward side. So for that, I'll once again select the mirror tool. Now select both of these objects, press enter, and now specify this as the first mirroring point and this one as the second mirroring point, and simply press enter. Here we have it, the geometry as per our requirement. Now in case you want to make a complete mirror image of all of these four geometries somewhere over here, for that, you can again select the mirror tool, select the complete set of objects, press enter. Now again, you need to specify the mirroring line. So I'll select this as the first mirroring line and this point as the second mirroring line. And now let's erase the source object in this case. So I'll click on yes, and the source object is deleted and a copy of that object is made here. So now let's press Ctrl Z a couple of times to return back to the original geometry. Now we'll try the mirror tool on this text also. So select the mirror tool, select the text, press enter, and now click at a point and then click at second point and press enter. But in this case, you'll notice that the mirror copy has not been made. It is simply a copy of this original object, and these two objects are not laterally inverted as it was in case of this object. So in order to make a mirror image of text, you need to ensure that the mirror text system variable is set to 1. So I'll make a copy of this object here. And now I'll apply the mirror tool once again on this text. So before that, I'll change the system variable. So let's type mirror text and change its value to 1 and press enter. Now select the mirror tool, select the text, press enter, specify the first point and the second point and press enter. Now we have it as a mirror image, and you can compare it with the original copy or the original mirror image which we have made without using the mirror text system variable. So in this case, the mirror text system variable was set to 0. In this case, it was set to 1. So I'll once again type mirror text and I'll change its value to default 0. Now let's look at the scale tool. So here we have a simple geometry, and now let's assume that we want to increase the size of this geometry. So in order to increase the size, you can use the scale tool. So simply select the scale tool here on the modify panel, select the object, press enter, and now look at the command line. It now prompts you to specify the base point. So base point will be the point which will remain fixed when the object will be elongated or contracted. So when the size of this object will change, the base point will remain fixed. So I'll select this lower left corner as the base point, and now you'll notice that the size of object changes along with our cursor. So you can either select the cursor, or you can dynamically apply the size using the cursor, or you can also enter a scale factor. So in order to increase the size, simply add a value which is greater than 1. So if you add a value 1.5, then the size will increase to 1.5 times of the original value. So if you type a scale factor of 2, it will make a geometry which is twice the size of original object. If you type 3, it will make a geometry of thrice the size, and so on. Similarly, if you type 0.5 as a scale factor, it will decrease the size to half of its original value, and so on. So I'll type 1.2 in this case and press enter. And here we have it. The larger geometry has been made. So now let's press Ctrl Z to get back to the original geometry. Now, in case you want to make a copy of this object after scaling, then you need to select that corresponding option. So I'll select the scale tool again, select the object, press enter, specify the base point, And now here we have an option of copy. So let's select this copy option, and now let's reduce its size to half of its original value. So I'll type 0.5, press enter, and now you'll notice that we have a copied image. Let's select and move it outside. So the size of this object is half of the size of this object in all of these dimensions. So let's now press Ctrl Z to return back to the original geometry. Now in this case, the size of this object is somewhat close to 950 units, and let's make a line which is equal to 1000 units. So I'll make a line of length 1000 units. And here we have it. So now you can see that there is a slight gap between this endpoint and this line. So let's assume that we want to scale this drawing in such a way that the base length becomes 1000 units and all the remaining length stretches in the similar proportion. For that, we can use scale reference option. So once again, go to the scale tool and now select the object and press enter. Now specify the base point, which we have specified in the previous case also, and from the command line select this reference option. Now we need to specify the reference length, which is the length of this line from this point to this point. So I'll simply click at this point, and now I'll click at this point. So that's the reference length. Now you need to specify the new length, and the new length is 1000 units. So simply stretch it and click at the end of this 1000 unit length line. So click here, and here we have it. So now the base length is equal to 1000 units and the remaining lengths are proportionally changed. So you can now erase that original line. It's no longer required. So in this way, you can use mirror and scale command in AutoCAD. In this video, I will tell you about the trim and extend command of AutoCAD. So let's select the trim tool from the modify panel, and here we have this trim tool. You can also expand the flyout and select the trim tool. Now after selecting the trim, simply press enter, and now click on the segment which you want to remove. So in this case, we have made all of these objects with rectangle, which is a polyline, and let's now assume that we want to remove some of the segment. For example, we want to remove this segment from this boundary to this boundary. So now when I move my cursor on this segment, the transparency of this segment increases and it becomes dull, and also preview is shown that shows the part which will be trimmed. So let's click, and the part is trimmed. Now let's move to this part, and here also it will be trimmed from this boundary to this boundary. In a similar way, you can click on any part of this geometry. For example, if you click here, it will trim this object from this boundary to this corner. And similarly, you can trim this part, and you can keep on trimming as long as there is a boundary. Now here also you can click here, and that will trim the geometry from this corner to this corner. Now let's press escape key, and this trim tool is helpful not only for trimming these line segments, but it can trim arcs, circles, and other geometries also. So basically all of the geometries can be trimmed using the trim tool. So now let's press Ctrl Z a couple of times to get the original geometry here. So now let's select the trim tool, and let's look at other method of trimming the objects. So now I'll select the trim, and once again I'll simply press enter. Now after pressing enter, look at the command line, and it now prompts you to select from multiple options. So let's select fence. In the previous case, we have not selected any of these options, but in this case I'll select the fence option. And now using the fence option, you can create fences, and all the parts which are crossed by the fence will be trimmed. For example, you can see that the line segment is crossing that fence, so it has been trimmed. This part is also trimmed. So let's now click here. Let's trim this one also. Let's trim this fence, and let's trim this one, and let's trim this one. So now you can see that all the line segments which are crossed by this fence are trimmed. Simply press enter to apply the change, and here we have it. So all of those segments are now trimmed. So let's press escape key, and let's press Ctrl Z to get back the original geometry. Now let's go to the trim tool again, and now don't press enter. So in the previous cases, we have directly pressed enter, and by pressing enter, we have selected all of the objects in the drawing area. And by selecting the objects, we were essentially allowing the trim tool to trim objects with the very next boundary. But in this case, we can select the boundaries which will be selected for trimming. So let's assume that we want to trim our objects only with respect to this red boundary. So I'll select this red object and now press enter. Now, when you click on the objects, it will only be trimmed up to the red boundary. So here we have this white rectangle. So let's now click on this portion here. And now you'll notice that the complete portion will be removed, which is outside this red rectangle. Similarly, if you click on this one, the complete portion which is outside this rectangle is removed. If you select the green rectangle, the complete portion which is inside this red rectangle is removed. And if you select this yellow one, there will not be any change because it's completely inside. It's not touching the boundary here of this red rectangle. But in this case, it will be trimmed. In this case, it will not be trimmed. Now in this case, you can see that we don't have any boundary, any object outside this red box. And that is why it's a single segment and that cannot be trimmed. So let's now press escape key and let's press Ctrl Z a couple of times to get back the original geometry. In trim tool, you can trim any object as long as there is a boundary. So if you create an object, let's say that we create this 3-point arc somewhere inside this object here, just like this, and we want to trim this object. So this will only be trimmed if a next boundary is found. So let's select the trim tool, press enter, and now I'll click somewhere inside this geometry and I'll click this part and the part has been removed. Now let's click on this part and let's click on this part. Now if you click on this part, it won't be trimmed because there is no boundary after that. So we have this one as the last boundary. After that, we don't have any boundary. Now let's click on this part here. And now we have these two segments here. So let's now click on this part here. And now this is once again a completely single segment with no boundary. So here we have a boundary, but we don't have any object on this side. Here we also have a boundary, but we don't have any object. So this is a single segment and it won't be trimmed. Similarly, for all the remaining segments also, the same rule applies. So let's press escape key and Ctrl Z a couple of times. The extend tool is completely opposite of this trim tool and it will extend the geometries to the next boundary. So for selecting the extend tool, I'll make a line here just like this, and also I'll make a 3-point arc. Now go to this flyout and select the extend tool. Now once again press enter and that will select all the objects in the drawing area, and wherever the next boundary is found, the object will be extended. So in this case, I'll click on this line and you'll notice that it will be extended up to the next boundary, which is the arc here. And now I'll click here. Once again, it's extended to next boundary, to next boundary, and to next boundary, and the same system will follow. If you select on this arc, it will also extend to the next boundary, but if you click on it now, there will not be any change because it cannot extend and it cannot make a complete circle. Now let's press escape and Ctrl Z once again. Now let's say that in this case also we want to select a particular boundary for the extend tool. We can do that. So I'll select the extend tool again. And now I'll select this yellow boundary and press enter. Now click on this line and you'll notice that it will bypass all the extra geometries which are present before this yellow rectangle. So it will directly extend the object up to this yellow object and it will bypass these three geometries. Now if you click on this again, it will extend it up to the next boundary of this yellow rectangle and it will bypass both of these objects. So by making a selection for extend, you can create extended geometries which behave in a particular way. So let's press escape key and Ctrl Z a couple of times. The trim and extend tool can be used using a single command also. So in the previous case, we saw that we can toggle this trim and extend tool from the flyout, but you can select the trim tool and use it for extending the object. So right now you can see that I've selected the trim tool, but now I'll press enter and now I'll simply press and hold my shift key. So pressing and holding the shift key will change the command to its next counterpart. And now I'll click on this line segment and now you can see that it's extending it even though we have the trim command active, and the similar condition will apply on the extend tool as well. So let's press escape key and get back to the original geometry. And I'll also erase both of these objects. So this was all about the trim and extend tool of AutoCAD. In this video, I will tell you about erase, explode and overkill command of AutoCAD. So here we have these two geometries. In the first case, we have this as a block, and we'll learn about blocks later on in this course. But for now, just assume that a block is a single entity here, and it is made up of many different drawing objects which we have seen so far. We have this arc here, we have the line segment, and all of these objects combine together to make a single block. But in this case, we have this object made up of simple object. In this case, we have this rectangle, we have these line segments and an arc. So they are completely separate from each other. Now, if you want to break any object and if you want to convert it into its simplest form, then you can use the explode tool. In this case, we have this block, and when you click on this block, we'll find that here we have a single grip and it's completely behaving as a single object. In order to break it into different parts, simply select the explode tool, and here we have this explode tool. Select the explode tool, click on the object and press enter. And now move to this object, and you'll notice that now it has been reduced to its separate units. We can now select all of these objects separately, even though it was a block initially. In a similar way, if you click on this rectangle, you'll find that it's completely a single polyline and it has 4 different line segments. But you can also explode this geometry to reduce it into its simplest form. So once again, select the explode tool, click on this rectangle and press enter. And now when you click on this object, you'll notice that it's a single line segment, and similarly all the objects have been broken down into their simplest segments. In order to erase any of these objects, you can select the erase tool from the modify panel and then select the complete set of objects and press enter. So that will erase the objects. Or you can also use the alternate method, which is selecting the objects and pressing the delete key on your keyboard. There is also one more method, and that's simply selecting the object and deleting it from the right contextual menu. So you can select any of these options for erasing an object. When making any drawing, there will be conditions when you'll make some overlapping geometries. For example, in this case, we have the simple geometry which is made with single segments everywhere. But what if we need to make some overlapping geometries? For example, I've selected the line tool, and now I've clicked at this point, and now I need to take reference of that point, so that's why I click there. And now from that point I need to select a distance of, let's say, 60 units. So I'll type 60, press enter, and now I need to move upwards and I need to enter a distance of 150 units, press enter, and now I need to join it with this point. So now in this case, you know that we have an overlapping line here which is above this line, and in a similar way there may be situations where you need to create many overlapping geometries. So you can manually remove those overlapping geometries, but that will take time. But there is a direct method in AutoCAD that can be used to remove all the overlapping geometries, and that's overkill. So go to the modify panel, expand it, and select this overkill option. You can also use its command equivalent, which is overkill, and then select the complete set of objects and press enter. Now don't change anything in this window, simply click OK, and now we don't have any overlapping object here. So now if you click here, you'll see that we only have a single line. And similarly, if there would have been any object which are overlapping any other object in this drawing, that would also have been removed. So this was all about erase, explode and overkill command of AutoCAD. In this video, I will tell you about the stretch command of AutoCAD, and using a stretch tool, you can change the shape of geometries in very particular ways. For example, in this case, we have this bathtub, and let's say that we want to increase the length of this bathtub. For that, we can use the stretch tool. So select the stretch tool from the modify panel, and now select the objects. But in this case, you need to select objects in a very specific way, and if you expand this command line, you'll notice that it's also prompting you to select it with only crossing window or crossing polygon. So now in order to make a crossing window, I'll click on the right side and I'll move my cursor towards left, just like this, and here we have this crossing window with dashed boundaries. Now in this case also, I'm not selecting the complete bathtub. Instead, I'm selecting it only partially. Now all the objects which are completely inside this crossing window will remain unaffected, and all the objects which are completely outside this stretch window will also remain unaffected. So in this case, this line segment, this complete arc, and this line segment, this part of geometry will remain completely unaffected, but the length of these 4 lines will change, because in this case only these 4 lines are partially inside and partially outside. So now simply click at any point to make this stretch window and press enter. Now click anywhere and click on any side where you want to stretch it. So in this case you can see that the length of only those 4 line segments which were partially inside and partially outside our window is changing, and rest of the geometry is completely unchanged. So you can decrease or increase the length here just like this. Now similarly, if you want to change the geometry here also, you can do that. So I'll once again select the stretch tool, and now in this case let's assume that we want to increase the height of this panel here, and we want to keep this panel unchanged. So for that we need to make this stretching window in a specific way, just like this. Now in this case we have these 6 line segments which are crossing this crossing window, and they are partially inside and partially outside. Rest of the geometry will remain completely unchanged. So let's click, press enter, click at a point, and now move upwards, and you'll notice that only the 6 line segments which were partially inside and partially outside have changed their length, and rest of the geometry remain completely unchanged. Now let's assume that we want to change its length even further, and we want to increase its length in horizontal direction. For that I'll select this stretch tool, click at a point here, make this window like this, and obviously now you understand that which part will be affected. So in this case all of these segments are partially inside and partially outside, so only the length of these segments will change. So now press enter, click at a point and stretch it just like this. So in this way we can use a stretch tool in AutoCAD to change the shape of geometries or stretch them in a particular way. In this video, I will tell you about break and join command of AutoCAD. So I'll start with the break tool, and you can find the break tool in the expanded modify panel. So select that arrow to expand the modify panel, and here you will find this, the break tool and break at a point tool. So we have these 2 break tools. So I'll select the break at a point tool in the first case, and now using this tool you can break any object in 2 different parts. So in this case we have this line segment which is completely a single segment. As you can see that when I hover my cursor over this object, the complete segment is selected. Now let's say that we want to break it in 2 different parts from its midpoint. So for that I'll select the object and now specify the first breakpoint as mentioned on the command line. So let's now click on this midpoint, and now the object is broken into 2 different parts. So let's select it, and now you'll notice that we have this as a separate segment, and you can obviously move it. So using the break tool you can break any segment in 2 different parts. Now let's say that we also want to create a gap in between these segments just like this. So for that I'll press Ctrl Z so that the object now combines into a single segment, and I'll select the break tool once again. So in this case, instead of selecting the break at a point tool, I'll select this normal break tool, and now once again select the object. And now don't select the second point. The command line is obviously prompting you to select the second breakpoint, but don't select it. Click on this first point option and now specify the first point. So I'll select this one, the point somewhere around this as the first point, and now I'll select second point somewhere around here. And now you can see that the object has been broken into 2 parts, and also there is a gap. So let's now press Ctrl Z to get back to the original geometry, and I'll select the break tool once again. So let's select the break tool, and now in this case I'll once again select the object, but in this case you need to select the object in a specific way. So let's say that we want to break this object in such a way that the gap is created of this length. So the gap should be equal to this length which we have here, approximately equal to this one. So for that select this object, but make sure that you click at a point which is close to this point. So I'll click somewhere over here, and by this click the object is selected and also the first point is assigned here. Now you simply need to select the second breakpoint as mentioned on the command line. So now you need to click close to this point. So let's now track it and click here, and here we have it. So in this way you can create the gap of approximately same size on this segment. So I'll press Ctrl Z again, and now I'll select the break tool for this circle. So once again expand it, select the break tool and select the object here. Now we want to break a single quadrant here, and for that I'll select the first point and now click at this quadrant point and then click at this quadrant point. Now you can see that this quadrant is removed. So in this way you can use break tool to remove some of the segments from the circle, line or any other geometry. The opposite of this break tool is obviously the join tool, and using the join tool you can join broken objects into a single entity. So first I'll press Ctrl Z to return this object to its normal shape, and now I'll expand this modify panel and select the join tool. So here we have this join tool. Now select it, and now here we have a gap. In order to fill this gap we can select the join tool. So click on this point here close to this gap and click on this line segment close to the gap and simply press enter. And now the gap has been filled and also the object is joined as a single entity. But in this case the objects need to be collinear, or they should be on a single line. If the objects were not collinear, the join tool will not work. For example, if I move it a little bit upwards and then I'll try to join it, it won't join the objects. And as you can see that it failed to join these objects. Now for these situations we have a different tool. If you want to blend this gap you can use the blend curves. So here we have this blend curves. Select the blend curves and now click close to this endpoint and click close to this point, and the gap has been filled with a spline about which we have already learned. So in this way you can fill the gap using the blend tool. So let's press Ctrl Z a couple of times and let's look at this geometry. So now in this case we have this object as completely separate unit. So we have these line segments and we also have this arc here. So all of these objects are completely separate. Now if you want to join them into a single unit you can do that with the join tool. So once again expand the modify panel, select the join tool, now select complete set of objects and press enter. Now click on this object and you'll notice that the complete object is converted into a polyline and it's acting as a single unit. So using join tool you can join objects which are already connected from end to end, and this was all about the break and join tool of AutoCAD. In this video, I will tell you about the fillet and chamfer tool of AutoCAD. So using the fillet tool, you can add rounded corners on the sharp edges, and using the chamfer tool, you can add a straight line at the vertices or sharp corners. So I'll start with this geometry here. And now go to the modify panel and select the fillet tool from this flyout. So here we have this fillet tool. Now expand the command line and you will be able to see the current settings of the fillet. So currently the mode has been set as trim mode and the radius is set to 0. So obviously we cannot make a fillet with 0 radius. So we need to change the radius first. So click on the radius option and now change the radius. So I'll type 1 as the radius for this fillet and press enter. Now look at the command line. It prompts you to specify the first object. So click on this line segment and that will be the first object. Now click on the second one and the fillet will be applied automatically. And as soon as the fillet is applied, the command will also end. Now if you want to repeat the fillet tool, simply press enter and you'll notice that the last settings are applied. So in this case, the radius is 1 and the mode is trim mode. So you can again apply the next fillet simply by clicking on the two line segments. After applying the fillet, the command automatically exits. And if you don't want the command to exit automatically, you can select the multiple tool. So once again, I'll press Ctrl Z a couple of times to return back to the original object. And now select this fillet tool. Now I'll select radius and change it to 1. Now here we have an option which is multiple options. So let's select this multiple option. and now select the first segment and second segment, and now you can see that the command is still active. So using the multiple option, you can create fillets on multiple edges without repeating the command again and again. So let's press escape key and press Ctrl Z. Now there is also a direct method of applying fillets on this kind of geometry. So in this case, if you click on any of the segments, you will notice that the complete geometry is selected. So this complete rectangle is made with a single segment. If you find this kind of geometry, you can apply fillet on all of these edges directly using single click. So for that, I'll once again select the fillet tool and I'll go to radius, select the radius of 1 unit, press enter, and now select the Polyline tool. So in this case, we know that our object is a polyline and it is completely connected. So select the Polyline tool, click on the object, and the fillet will be applied on all of these 4 vertices. So let's press Ctrl Z to return back to the normal geometry. Up to this point, we have seen that after applying the fillet, the extra portion is automatically chipped off. It's automatically removed. Now, if you want to keep that extra portion, for example, in this case, let's apply the fillet first. So I'll select the fillet tool, select the radius, select 1 as radius, and I apply fillet on this corner. Now the extra portion has been removed. Now, what if you want to keep that extra portion also? For that, you need to change the trim mode. So select the fillet, and here we have this mode as trim. So obviously we need to change this mode, and for changing this, click on this trim option and change it to no trim, and now apply the fillet. So I'll select this line segment and this line segment, and here we have it. The fillet has been applied, but this extra portion is also retained because we have changed the mode. And now you can apply the fillet by retaining the extra portion or the extra segment here. So obviously we do want to select the trim mode. We don't want this mode. So I'll go to this fillet option, click on this trim option, change it to trim mode. And now if I apply the fillet, it will remove the extra geometry. Now let's look at this condition here. Now in this case, both of these objects are not joining each other, but when we extend them somewhere, they connect each other. Now you can apply fillet on these objects as well. So select the fillet tool, and now select the radius option. And in this case, let's select a radius of 2 units and press enter. Now select the first object, select the second object, and we have the fillet here. So obviously the fillet is applied and the extra part of this line segment is also removed. Now press Ctrl Z, select the fillet tool, and in this case, let's change the radius to 0 and press enter. And let's try to apply the fillet here. So I'll select the first line segment and the second one, and in this case you'll notice that the objects will connect at their apparent point of intersection. So here the radius has been set to 0, and by setting the radius to 0, you can extend the objects to intersect at their apparent point of intersection. So you can do that with fillet tool. Now all of these things can also be done for chamfer tool. So I'll press Ctrl Z a couple of times to get back the original geometry, which is this one, and I'll start the chamfer tool from the first rectangle here. So once again, go to the flyout, select the chamfer tool, and now look at this mode here. So we have this trim mode obviously, but we have the chamfer distance as 0 for distance 1 and distance 2. So we need to change these parameters. So select the distance option and enter 1 as the first distance, and now enter 2 as second distance. And now I'll click on this line segment first, and then I'll click on this line segment as second distance. And now this chamfer has been applied. So in this case, we have applied the first chamfer distance as 1 unit, which will be this distance, the distance between this endpoint and the original vertex. The second chamfer distance was 2 units, which is the distance between the vertex and this endpoint. So the first and second distance is selected based on the point on which we click. So in this case, I clicked on this line segment first, so that became the first distance, and I clicked on this line segment, so that became the second distance. Now here we have the normal geometry. So in this case also, if you want to apply chamfer on all of these vertices, you can use the polyline option. So select the chamfer tool and select the distance, and I'll select 1 as the chamfer distance for first distance and also 1 for second distance. So in this case we will have a completely uniform chamfer, and in this case also we have a multiple option. So using multiple option, you can repeat the command and the chamfer command will not exit even after making a chamfer. And you can select the polyline option if you want to apply the chamfer on all of these vertices at once. So simply click here and the chamfer has been applied on all of these vertices directly. In this case also, you can change the trim mode to retain the extra segment, and in this case also you can apply chamfer on this kind of geometry. So I'll select the chamfer tool and I'll select the distances here, and now I'll apply it in between these two segments. And here we have it, the distance 1 applied in between these two segments. So this was all about fillet and chamfer tool of AutoCAD. In this video, I will tell you about the lengthen and reverse tools of AutoCAD. So here we have these 3 simple geometries, and we'll start with the lengthen tool here. So you can use lengthen tool to find out the length of different objects in the AutoCAD drawing, and you can also use it to increase the existing length of the objects. For example, here we have a line and an arc. Now using the lengthen tool, we can increase their length, and here also we can increase the length of this arc or the circumference of this arc, so that will affect the included angle. So to start the lengthen tool, expand the modify panel and select the lengthen tool from here. Now select it and click on the object whose length you want to find. So in this case, I'll click on this line, and here we have the length of line, which is 100 units. Now let's assume that we want to find the length or the circumference of this arc. So click on it, and we have the circumference of the arc along with the included angle. So in this way, you can use this tool to find the length of different geometries. Now using this tool, you can also increase its length. So as you know that the length of this line is 100 unit as shown here. Let's say that we want to change its length to 120 units. For that, I will select this delta option first. Now using delta option, you can change the length to any value. So here we want to change its length by 20 units. So type 20, press enter. Now click on the side on which you want to increase the length. So I'll click close to this endpoint, and the length will increase by 20 units towards right side. You can now also click on this left side to increase it by 20 units here, and you can keep on clicking if you want to increase length even further. Now let's press enter to exit this command. Now I'll press enter again to repeat the command, and now once again I'll change the length of this arc. So in the previous case we have changed the length of this line, now we'll change the length of this arc. But in this case, instead of using the delta option, I'll select the percent option. So let's select this percent option. Now using the percent option, you can also change the length of existing objects, and for that you can enter a value which is greater than 100 and also less than 100. So if you enter a value which is less than 100, for example 80, that will decrease the length, and it will decrease the length by 20%. And if you enter a value like 120%, it will increase the length of the existing object by 20%. So obviously entering a value of 100% will not make any change. So in this case, I'll enter a value of 70% and now press enter. Now click on the side of arc from where you want to decrease the length, and here we want to decrease it. So you can see that the length will be reduced. So let's click, and the length has been reduced to 70% of its original value. Again press enter to exit this command. Now you can also press enter to repeat it, and now we have a total length option here. So let's select this total length, and now you can enter a total length for the object. So in this case, we know that the length of this line is now 140 units because we have increased the length by 20 units towards right and left side. Now let's say that we want to decrease its length and we want to make it equal to 60 units. So I'll type 60 as the total length. Now press enter. And now click on the side from where you want to decrease it. So if you click on the right side, the length will be decreased from this side. If you click on the left side, the length will be decreased from there. So I'll click on this left side. And now here we have the line with a length of 60 units. You can also check it using the lengthen command. So again, press enter and click on this line. And here we have this 60 unit length. If you want to change the length of this line now or the length of this arc dynamically by using your cursor, then you can select this dynamic option, and now you can click on the line and you can move your cursor to change the value. Similarly, you can also click here and change the length of this arc just like this. So now let's erase both of these geometries. So now let's have a look at the reverse tool. So using reverse tool, you can reverse the direction and also orientation of the object. So here we have a polyline, and in this polyline we have this starting width of 0 unit and an ending width of 10 unit. Now let's say that we want to reverse its direction. For that we need to expand the modify panel and select the reverse tool. So select it. Now select the object and press enter. Now, although you may not see the change in direction, but when you look on the command line, just let's expand it, you'll see that the object direction has been reversed. So obviously the object direction has been reversed, but we are not able to see any change here in this polyline because it has not reversed the order in which the polyline has been made. And in order to apply the change on the order of this polyline, you need to change p line reverse width system variable to 1. So let's type p line reverse widths and press enter. So now you can see that its default value is set to 0. Let's change it to 1 and press enter. Now we'll repeat the command. So let's go to this modify, select the reverse tool, select the polyline and press enter. And now the direction has been reversed and also the orientation has been reversed in this case. This reverse direction tool is especially helpful for this kind of cases, and it's also helpful in the situations where you have a line type containing text and when the direction of text is not appropriate or not according to your requirements. So you can use this tool to reverse the direction of polyline or reverse the direction of line type to make it appropriate as per your requirement. So let's now once again change the system variable back to 0. And let's erase this object as well. So this was all about lengthen and reverse tool of AutoCAD. Okay, so now we have completed this module. Now we need to make this drawing using all of the commands and tools which are taught up to this point. I'll start with the Polygon tool, and here on the draw panel, expand this flyout and select the polygon. Now we need to select 3 sides because we want to make a triangle. So select 3 and press enter. Now we don't need to specify any center point. Rather, we need to specify the edge length. So select edge and click at any point, and then the next point. The next point will be of 9 unit length. So type 9 and press enter. So there we have it, the triangle. Now we need to start with the circle tool. So go to circle, click on this point here and make a circle with radius of 3 unit and press enter. Now press enter again to repeat it, and now click on this point and enter a circle of radius 2 unit and press enter. Now you can make another circle at this point, or you can copy the existing circle. So I'll select copy, select the circle, press enter, click on the midpoint and move it on this one. Now press enter or cancel. Now we need to join both of these circles with the help of a circle which is tangent on both of them, and we can do that using tangent radius because the radius is also provided here. So go to the flyout and select tangent radius. Now click at the approximate points where they are touching, the first and the second point, and enter radius of 3 unit and press enter. There we have it. Now we can repeat this command and we can do it here also, or we can make a mirror image. So I'll make the mirror image, but before that I'll trim this. So I'll go to trim, press enter, and now trim this portion. Now we can make the mirror image of this small arc. So select it, click on mirror. Now click on this center point or the end point of triangle and join it with this midpoint and press enter. So now it is joined. Now for this side, we need to join it with a straight line. So I'll go to line tool, I'll go to this quadrant and I'll join it with this quadrant and press enter. Now we only need to trim all the extra portions. So the first thing is this triangle, which we need to delete. So I'll delete it and I'll go to trim, press enter, trim this and these 2 portions. There we have it, the final drawing as per our requirement. So in this module, we'll start looking at the options of this status bar, and we'll start with the first two options, which is grid and the snap mode. So here in this drawing area, you'll notice that by default it's completely blank, or in your case it may have a grid, and we have the UCS and the normal objects here. Now you can also add grid if it is not present in your drawing area directly by clicking this first icon, which is grid mode. You can also turn it on by pressing the F7 key on your keyboard. So here we have a grid, which is mostly like a graph paper. So you can zoom in and zoom out to see its individual blocks. And now here we have these individual blocks. Now currently there are 5 blocks in horizontal and 5 blocks in vertical direction, and after every 5 block there is a major line in both the directions. Now these grids are helpful in creating lines and other drawings in AutoCAD, but you can also change the settings of these grids. So in order to change its setting, simply right click on the grid mode and select this grid settings. So now on this drafting settings window, we have lots of options. We'll simply select this grid spacing option. So currently you can see that the grid X spacing is set to 10 unit. That means the single box or the single grid here has a length of 10 unit in X direction, and also in Y direction it is 10 unit. Now here we have this major line every 5 blocks. So that simply means that after every 5 block in both the direction, we have this major line. Now if you want to change these settings, you can do that. So we'll change it for now. So I'll change the grid X spacing to 1, and also the grid Y spacing will change to 1. Now we want major line after every 10 blocks, so we'll change it to 10. And now let's click on OK. So the settings of this grid has completely changed, and now if you'll zoom in, you'll find that here we have these new settings. So now we have each block with length of 1 unit in horizontal and 1 unit in vertical direction, and also after every 10 block we have these major lines. Now there is one more option, which is this snap mode. So you can turn it on by pressing the F9 key, the function 9 key on your keyboard, and by using this snap mode you can snap at particular points on this grid. So we will once again change the settings for this snap mode as well. So I'll just click on it to turn it on, and now right click and select this snap settings. So now here we have the settings related to the snap, and in order to have a uniform value for snap and grid, we need to change the values for both of these properties. So in this case we have changed the X spacing to 1, and in this case it's set to 10. So let's now change it to 1 in this case also. Press tab key and the Y spacing will also change to 1. We'll see what this means in a moment. So now change these values and click on OK. Now select any command. For this case I'll select the line, and now you'll notice that our cursor behaves in a very random way. So even though I'm moving my cursor uniformly in the drawing area, it will only snap to the intersection of grid lines, as you can see here. And after every one grid line, the cursor will snap, because we have changed its value in that way. Now let's say that we want this cursor to snap after every 2 grid lines or after every 2 grid blocks. So we can right click, go to snap settings and change it to 2, and now click on OK. And now after every 2 blocks you can see that it's snapping in horizontal as well as in vertical direction. So in this way you can change these values. Now how are these helpful? So first let's change it to 1 so that it has a uniform value. And now we'll make a simple geometry. So I'll make a simple rectangle in this case with a length of 10 and width of 5 unit. So I'll click on this point, and we don't need to be concerned about the point because it's exactly clicking at the intersection of the grid lines. So now click here, that will be the 10 length, and also we have this 5 length, the 10 length and 5, and now press enter. So we can easily make this kind of geometry directly taking the reference of these grid lines or the background grids here. So it's quite helpful in making these kind of geometries. But for most of the cases I keep these settings off, and I also keep the grid off, and I prefer to work without these grids, but it's completely up to you how you use these grids. So that was all about the grid and the snap mode settings. In this this video, I will tell you about the polar and ortho mode of AutoCAD. So on the status bar, you'll see here this ortho mode, and you can turn this ortho mode on by pressing the F8 key on the keyboard. So let's click on this ortho mode, and when you click on this ortho mode, you'll notice that the polar tracking will automatically turn off. So for now, we'll just keep this ortho mode on, and now let's go to the line tool and click at a point to start the line, and we have a completely horizontal line here. Now even if I move my cursor way beyond that horizontal line, it still remains horizontal. Even if I move it to this direction, it will remain horizontal. Now if I move it close to this point, it will become vertical. So as long as ortho mode is on, the lines will always remain either horizontal or vertical, but you can obviously snap to any existing point. For example, if you move your cursor close to this point, the end point, it will snap to that point. But as long as there is an absence of snap point, it will always make your geometry in either horizontal or vertical direction. So using this ortho mode, you can make these geometries quite easily. Now let's erase it, and let's now turn on this polar tracking option. So you can obviously use F10 function key to turn it on, and as soon as you turn it on, the ortho mode will be off. Now using this polar tracking, you can create your geometries in any direction. So here also I've started the line, and I can create it in horizontal direction, and also I can create it in any direction. But there is a slight advantage in this case. In this case, when you move your cursor to the 0-degree angle, you'll see this tracking vector. Now this will help you in creating a completely horizontal line, because in the absence of this tracking vector, you won't be able to, or at least it will be very difficult for you to make a completely horizontal or vertical line. So let's now turn it off, and now let's try to make a completely horizontal line, and now you won't be able to make a completely horizontal line, or even if you will be able to make it, it will take some time. So this polar tracking will help you in making lines inclined to particular angles, not only in horizontal and vertical direction. So now let's turn it on, and now here we again have the tracking vector. So in this case, you can see that the tracking vector is only in this horizontal or in this vertical direction. Even if you move to any direction, we have it after the interval of 90 degrees, but you can change that. So let's say that we want this tracking vector to appear after an interval of 30 degrees. So for that, click on this small arrow right beside this polar tracking and change it to 30. And here we have this 60, 90, 120, 150 and so on. So let's click here. And now we have the first angle at 0, then the second tracking vector at 30, then at 60, 90, and so on. So after every 30 degrees, we have this tracking vector, and that will make the drawing workflow very easy, and you will be able to directly snap to those angles easily using this polar tracking tool. So when you go to this polar tracking, you'll see that you'll have lots of other options also. For example, the 45-degree multiples, the multiples of 23 and 18, 15, 10 and 5. So these are more than sufficient for your requirement. But if you want to add any custom angle, for example, let's say that we want to add an angle of 17.5 degrees. So that also you can do. So for that, click on this tracking settings. And now here, click on this additional angles, click on new and add the additional angle. So we need to add 17.5. Now press enter. And our new angle is added. So let's now click on OK, and now click on this arrow again, and you'll see that here we have this 18, 36, 54 and 72 angle. Although currently you won't be able to see the exact 17.5 degrees because precision of angle is set to 0, and we need to change that precision value in order to see the decimal points. So I'll just change that value. So for that, I'll press escape key and I'll type UN for units. And we have already seen this drawing units window. From here you can see that the precision for angle is set to 0. Let's change it to 2 decimal places. Click on OK. Now let's look at the angle value, and here we have the 17.5, 35 and its next multiples. So once again, I'll go to this line tool, click on any point, and from here I'll make sure that this option is selected. And now after every 17.5 degrees, we have this tracking vector. So let's make a line to an angle of 52.5 degrees and press enter. Now if you want to remove that value, you can again go to this tracking settings, and from here select the value, click on delete, and now click on OK. So in this way you can use ortho mode and also the polar tracking to make your drawings according to your requirement. I prefer to keep this polar tracking on, and I only keep ortho mode on in specific cases. So once again I'll remove these geometries, and that was all about the ortho mode and polar tracking status bar options of AutoCAD. In this video I will tell you about dynamic input status bar option. So up to this point we have been using command line for entering all of our inputs, whether it's the distance, angle, or the coordinates. But there is an alternate method of doing this, and you can do that using the dynamic input, which is simply a small command line on your cursor. So here we have this dynamic input option on the command line, and you can activate it by clicking on this option, or you can also use a din mode system variable. So you can change the value of this din mode system variable to 1 in order to make it active. Now once this is active, go to any command and now click, and now you'll find a slight difference. Now we have this cursor, and along with the cursor we have the command line input here. So the same input which is on command line can now be seen directly on the cursor, and along with that we have a dynamic coordinate here. So you can see that this coordinate display changes according to the movement of cursor. Now let's click at any point in the drawing area, and now the cursor again changed, and it's now reflecting a new value here. So now wherever possible the cursor will show this distance value and also the angle value, and as far as possible it will show other values also, for example radius or the arc length, depending upon the geometry. So now let's say that in this case we want to make a line with length of 100 unit inclined to an angle of, let's say, 45 degrees. So for that simply type 100, and now you'll notice that that value will be entered on the line field. Now simply press tab key, and the distance will be logged, and the input field will jump to this angle value. Now enter the angle, which is 45, and press tab again, and here we have it. So now the geometry is logged to a distance of 100 unit and also to an angle of 45 degrees. Now press enter, and the final geometry is here. So this is a little bit simple method of making the geometries which you can use obviously, and depending upon the geometry or your preferences, you can either prefer this method or the direct command input from the command line. So I'll now press escape key, and I'll look at other options which are available with this dynamic input. So let's now move this geometry here, and now I'll go to this polyline. Now I'll click at any point in the drawing area and look at the command line. So on the command line we have some other sub commands or some extra options which are related with this commands, for example arc, half width, length, undo, and width. Now these options are also available on the dynamic input, and you can access these information or these options simply by pressing this down pointing arrow. So click on this down pointing arrow as mentioned on this tooltip also here. So click on it, and now all those options are available as a list. Now you can simply keep pressing that down pointing arrow, or you can also press the up arrow and choose the desired value. So I'll select this width option and now press enter. Now let's change the starting width to 10 unit and the end width to 10 unit again. Press enter, and here we have it. So now you can see that we can apply the same value directly from the command line. So once again, let's change the width to 0. I'll select the width value, enter 0 as the starting width and ending width also as 0, and press enter, and we have the normal polyline here. So let's now join it with the starting point and press enter. When making drawings with this dynamic input, there might be situations when this would create a little bit of distraction for you. For example, in this case, let's say that we want to make a circle at this point, but we don't want this dynamic display to be visible at this drawing area. So you can hide it also temporarily by using the F12 function key. So press the F12 function key while your command is active, and that option will hide temporarily. And now you can enter the values if you want, or you can again release the F12 key and enter the value. For example, here I'll enter 60 as the radius, and here we have the final geometry. So in this way, you can use the dynamic input option for bringing your command line directly on the cursor. So that will decrease your dependency on the command line, but obviously it is not a replacement for your command line. Command line will be required for many other situations also, but you can use it wherever you find it most helpful. So I'll just click on this option once again to turn it off, as I prefer working with the command line only. In this video, I will tell you about simple object snap tools. The object snap option comes into picture when you want to make geometries with respect to the existing geometries or their points. For example, here we have these geometries, and now I'll select the line tool, and let's say that I want to start this line from this endpoint somewhere here. So when I move my cursor close to this endpoint, this small endpoint box will appear, and also on the tooltip you'll see that its name will appear here as endpoint. Now even if I don't click on this exact endpoint, the cursor will still snap to that endpoint, and that's because we have this object snap option active. Now you can turn it off by simply pressing the F3 key, and when this option is off, there will be no point at all on any of these existing geometries. So now I'll simply click on this to turn it off, and now I'll click anywhere in the drawing area, and now I'll move my cursor close to the next endpoint, and now we don't have any endpoint or any midpoint or any other point here for the reference, and it will be very difficult for us to exactly click at the point. Let's say that I have clicked at this point. Now let's see how accurate I am. So I'll zoom into this area, and absolutely this drawing is not correct. We want to click at this point, but our geometry is here, which is not the correct one. So we need to ensure that object snap is always on to make accurate drawings. So now I'll zoom out, I'll remove these geometries, and now I'll click on this object snap option to turn it on. As I already mentioned, you can also turn it on by pressing the F3 key. Now there are a couple of points which are recognized by this object snap, and you can see all those points in this menu. So click on this small arrow, and there will be a list of points, and all of these points are recognized by the object snap. So there are check boxes or check mark in front of some of these icons, and some of the icons are without these check marks. So currently the object snap will only recognize the points which have these check marks, and it's always advisable to keep only the required number of check boxes active. So don't make all of these check boxes active, otherwise there will be a conflict of different object snap points. So for now we have this endpoint, midpoint, center, node, quadrant, intersection, and extension points active, and currently all of these points can be recognized by the object snap. So let's now go to another line tool, and now I'll move my cursor close to this circle, and here you'll see that we have this quadrant visible. Not only the quadrant, we also have this center point visible. Now all of these points are visible only because object snap is active. So let's turn off this center, and I'll repeat the command, and now I don't have any center point here. So obviously after turning it off, we won't find that, but still we have the quadrant and all the other points here, like endpoint and the midpoint here, which is indicated by this triangle. So you can keep other options active as well here. Now there is one more option here, which is a geometric center. So using this geometric center option, you can snap to the geometric center point of any closed geometry. So here we have a pentagon, and now when I move my cursor close to this point, you'll see that there is a new point here, which is the geometric center. So it's simply the centroid of this geometry, and you can find the geometric center for very irregular kind of geometry also. For example, here I'll make a drawing with polyline, and I'll make a very random geometry just like this. Now in this case also you can find the geometric center using that object snap, but the only condition is it should be closed like this, and it should be a single unit. Now I'll go to the line tool and move my cursor here, and we have this geometric center here. So in this way you can find the geometric center quite easily using this object snap tool, and you can also see some of the other object snaps like the node, which is simply a point which we have already seen. So you need to make sure that point or node is active in order to snap to it. We have the quadrant option, which is the quadrant of this circle or an arc. And we have the intersection. So intersection is simply the point which is something like this. So in this case, we have these two lines intersecting, and if you want to snap to this intersection point, make sure that intersection is active. And now when I select any command and I move close to this intersection point, there will be this intersection object snap. Now let's look at some other options here, and we have the extension here. Now using the extension, you can create any line or even an arc in the same direction, or you can extend that geometry. So I'll select the line tool for explaining this, and here we have this polygon. Now let's say that we want to extend this line, and for that I'll just click at any of its endpoints and now move my cursor in its direction, and you can see that we have this extension on the tooltip, and also the cursor is moving exactly along the direction of the line. So that's simply extension. You can also use this extension for an arc. For example, I'll select the arc tool here, click on this point, and now let's see here. So we can see that this geometry is extending exactly along the circumference of this arc. You can access these object snap options directly from the right contextual menu as well. So in the situations where there are plenty of object snap points and it becomes a little difficult to select the exact snapping point directly from this object snap menu, then you can use the alternate method, and that's the right contextual menu. For example, here we have this circle. Now let's make a line also in this case. So I'll click at this point, quadrant, and I'll join it with this point. Now in this case, we have the midpoint of this line exactly on the center of the circle. So I'll simply move this line a little bit towards left, just like this. And now the center of this point is very much close to the center of this circle. So now I'll go to the line tool, and now I'll try to snap to this point. And now if I move my cursor, I can only snap to this midpoint. Although I don't want to snap to the midpoint, I actually want the center of this circle. Let's now check whether we have the center active or not. Yes, we don't have it active. Let's make it active. Now move here. Now again we have the midpoint here, although I have turned it on, but still we have the midpoint here. So in these situations you can use the right contextual menu. So for that, simply press and hold the shift key and then right click. Now you'll see all the object snaps on this list. From here, select the object snap which you want to choose. For example, in this case I want center, and simply go to that point, close to that point, and it will snap only to that point, ignoring all other points. So in this case, I am now able to snap to the center, and here we have the geometry. In the previous video, we have seen some of the basic object snap points, and in this video we'll explore some of the advanced and typical object snap points. Now here we have this object snap active, and if it is not active, you can click on this status bar option to turn it on, and we have the list here. You can also turn it on by pressing the F3 key. So now in this list, we have seen up to the extension snap points. Now we have this insertion point, which is simply the base point of our blocks and the external references, and that we'll see later on in this course. We have the perpendicular object snap. Now for accessing rest of these options, I will not select this menu. Instead, I'll select it from the right contextual menu. So let's look at the perpendicular tangent options now. So I'll select the line tool for this, and now click anywhere in the drawing area to start this line. Now let's assume that I want to make this line exactly perpendicular on this line, but I don't know the point where it will be perpendicular. So in order to find that point, simply press and hold shift key, then right click and select the perpendicular option. Now move your cursor on this line, and here we have it. So click here, press enter, and now this line is perpendicular to this line. So in this way you can use the perpendicular object snap. Obviously you can use this perpendicular object snap also from this menu if you want. Now we have the next one, tangent. So here in this case, let's say that we want to make a line which is tangent on this circle or on this arc and also on this circle. So we want to make a single line which is tangent on both of these geometries. For that, I'll select the line tool. Now I'll press and hold shift key, then right click and select the tangent, and now click anywhere on this circle. So here we have this line. Now once again press and hold shift key, then right click, select the tangent. Now click on this circle and here we have it. So we have a single tangential line which is tangent on this and this geometry. Similarly, let's assume that we want to make a line which is parallel to any existing geometry. So in this case, I'll erase these two geometries and also this one. And now we want to make a line which is parallel to this one, starting somewhere from inside this polygon. For that, I'll select the line tool. Now click at the midpoint here, or let's say that we don't want to click at the midpoint, we'll click at some other point randomly somewhere here. Okay, now we don't know the exact direction of the parallel line. So we want to make this line exactly parallel to this one. And for that, I'll select the parallel object snap. So press and hold shift key, right click, select the parallel. Now we want to make it parallel to this line. So go to this line, but don't click, and now move back your cursor. So when you move it back, you'll see this small plus sign, the green plus sign, that indicates that a reference has been taken from this line. Now move your cursor, and when the line becomes parallel, this green tracking vector will appear. Now you can click anywhere to make this parallel line, or you can also enter the distance. So let's say that we want to make it of length 50 units. So I'll type 50, press enter and enter again. And we have this line exactly parallel to this one. So we have some other options also. Let's see that also. So here we have this nearest option, which should be turned off in most of the cases. And the nearest option is helpful if you want to click at any point on the curve. For example, in this case, we have an arc, and on this arc, we have some well-known points like the quadrant and the center. But what if you want to click somewhere in between the quadrants? For that, you can select the nearest option. So obviously I'll select the line or any other tool here for now. Now shift and right click, select the nearest option, and now move your cursor, and you'll see this nearest marker. So that will follow your cursor, and on this curve, you can click anywhere and it will exactly snap to this geometry. Now click here and the geometry has been made. And the end point of this line always lies on the circumference of this arc. So in this way, you can select object snap points to snap to any point in the geometry. And if you want to track your existing snap points, you need to ensure that this object snap tracking is on. So for now, we have this option off, and now I'll select this line tool. And now let's say that we want to make a line by taking the reference of any existing object snap points. For example, here we have this endpoint. Now we want to make a line which is somewhere over here, but which is along this line in the horizontal direction. But now when I try to take reference of this endpoint, I don't have any reference here. I'm not able to make any line exactly in this direction unless I make a line here. So if you want to take reference of this, simply click on this object snap tracking, move back to this point, and now move in this direction, and you'll have this tracking vector. So that will take reference of the existing object snap. So you need to ensure that object snap tracking is on if you want to take its reference. Now here also I'll press enter again. I'll go to this midpoint or the center, but I'll not click, and here we have the reference. You can click here, you can take the reference in vertical direction or in any other direction. So always make sure that this object snap tracking is on whenever you want to take reference of the object snaps, and you can turn it on by pressing the function 11 key on your keyboard as well. So let's move back to the drawing area and press escape key. In this video, I will tell you about the from snap option, and this from snap option may look a little bit intimidating to you in the beginning, but with practice you can use it in a variety of situations, and it will really be helpful in improving your productivity. So here we have a simple geometry. Now in this case, the length of this drawing is 10 units. The height is 10 units. We have this of 5 unit, and the remaining length of this slant line. Now let's assume that we want to make a circle somewhere over here, and we want to take the center of this circle in a predefined way. Now we want the center of this circle to be exactly at a distance of 10 units from the midpoint of this line, and that line, the 10 unit line, should be inclined to an angle of 30 degrees. Now for that, obviously we can make a line here. So we can start a line from the midpoint. We can make it of length 10 units and we can incline it to an angle which is required. So let's say either 30 or 45, we can do that. And then we can make the circle at its endpoint. So that's one way of doing that. But there is also an alternate method which is from snap, which does not require you to make any helping line. Now to do that, I'll select the circle tool directly. And now press and hold shift key. Then right click and select this from option. Now we need to specify the base point. So here you can see that we have a base point option. From base point, we need to specify that. So we need this base point here, the midpoint. Now we need to specify the exact location of that point. So in our case, the point is located at a distance of 10 units and it is inclined to an angle of 30 degrees. And now press enter. And here we have it, the exact point. So now you can enter the radius directly. So let's say that the radius will be 5, press enter. Now let's verify the results. For that, I'll select the line tool. I'll click at this midpoint and I'll join it with the midpoint. Now we need to check two different things. We need to check whether the length of this line is 10 units or not, and also the angle which this line is making with respect to the x-axis is 30 degrees or not. And we can do that directly with a single command, which is di distance, and we'll learn about these inquiry tools later on in this course. So I'll select this command. Now click at the first point and the second point, and now here we have this. The distance is obviously 10 unit. Let's expand this a little bit to see it more clearly. The distance is 10 unit for this line and the angle in XY plane is 30 degrees. So obviously our results are accurate. So in this way, you can use from snap to make these kind of geometries quite quickly. So let's repeat this process, but this time instead of making the circle here, I'll make the circle somewhere inside this geometry. So once again, let's assume that we want to make a circle on this side, and in this case we want the distance to be equal to 3 units from this point, or let's make it 5 units from the midpoint, and it should be in this direction, and the angle which it should make with respect to the x-axis should be 235 degrees. So for that, I'll select the circle tool and once again press and hold shift key, then right click, select the from snap option. Now click on this midpoint, and now obviously we need to specify the exact location of that center point, which is at a distance of 5 units. So I'll type at and then distance. We are entering at because we are using the relative coordinate system, and in relative coordinate system we have already selected this point as the origin, so we are entering the endpoint with respect to this origin. So now the distance is 5 and we need to enter the angle, which is 235 in this case. Now press enter and we have our midpoint. Now only we need to enter the radius, which is 2 in this case. Press enter. Here we have the geometry. So without taking any reference of any line or any other geometry, we can make these kind of geometries quite quickly using the from snap tool.